All right, guys, let's look at lesson 3, which talks about ions. Ions are different from atoms. Atoms are what we talked about in the last lesson, lesson 2. Atoms have the same number of protons as well as the same number of electrons. So they are neutral. They have the same amount of positive things that they do negative things. Same amount of positive protons that they do negative electrons. Ions are different. They are charged particles. They are formed when either an atom gains or loses an electron. So let's look at this example down here on the bottom. We have a sodium atom on the left that has 11 protons in its nucleus, 12 neutrons, and around in the orbits around the central nucleus, there are 11 electrons. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus this lone guy over here is 11. Now, if sodium were to lose this electron, okay, it would be an ion because it would have 11 protons in the nucleus, 12 neutrons in the nucleus, and instead of having 11 electrons, it now has 8, 9, 10. Since it has one extra proton than it does electron, it's charged. It has a +1 charge. And that's what the +1 means. The +1, when you write ion notation, tells you that you have one extra proton than you do electron. So the atom is electrically charged with a +1. There are two types of ions. An atom can either be a cation or an anion. It is a cation, emphasis on the T, when it becomes positively charged. When an atom loses electrons and becomes positively charged, it is an cation. So let's look at that example of sodium again. In the center of sodium, we have 11 plus charges because of the 11 protons. In the atom, we would also have 11 electrons surrounding the outside of the atom. Now, if sodium were to lose that outer electron, as we can see over here, it lost this electron. Now, we would still have 11 positive charges in the nucleus because we still have 11 protons. We are still talking about sodium. But in the outside, we now will have 10 minus charges because we lost that electron. So since we have one extra proton than we do electron, sodium will be a +1 charge. Now for our class, you can either write 1 plus or +1. Either way will be acceptable. Remember, this +1 comes from the fact that there are one more plus charges in the nucleus than there are negative charges surrounding the nucleus. The other type of ion is an anion, emphasis on the N. Anions are negatively charged, and that's when an atom, for example, this chlorine atom right here, is going to gain another electron. When this atom gains another electron, it will have more electrons than it does protons, which will give it a negative charge. So in the nucleus here, we have 17 plus charges because we're talking about chlorine, and chlorine has 17 protons. And in the atom, we will also have 17 extra electrons. When chlorine becomes an ion, since we're still talking about chlorine, we're going to have 17 protons. And because instead of having 17 electrons, we gained one, and we now have 18 electrons. We have one extra negative charge, then we do positive charge. Because of that, chlorine will become negative. So let's do some example problems. These example problems, I want you to pause the video and try to do these on your own. Okay, welcome back. Let's try these together. Iron here is going to be the atom of iron because it is neutral and has no charge. The iron down here is an ion because it has a +3 charge. So let's do the atom of iron first. The atom of iron has 26 for its atomic number. I got that off your periodic table. It has a mass number of 56. Again, I got that information off your periodic table. Now for the number of protons, remember, is the same as the atomic number. So again, it should be 26. Now to get the number of neutrons, we take the mass number minus the number of protons, and that will give us a number of 30, and that's the number of neutrons we have. Now remember, this is the atom of iron, so iron is neutral. The atom of iron is neutral. There's no charge over here, so it's a neutral atom. So that means the number of protons is going to be equal to the number of electrons. So the number of electrons for neutral iron is going to be 26 because it equals the number of protons. Now let's look at the ion of iron. Since we're still talking about iron, the atomic number is still going to be 26. The mass number is also still going to be 56 because we're still talking about iron. Since we are still talking about iron, the number of protons is going to be the same. And every time we calculate the number of neutrons, we take our mass number minus our number of protons to get our number of neutrons. Since the mass number and the number of protons did not change, we are still going to have the number of neutrons is going to be 30. Now this is where we're going to have some changes. Iron here has 3 extra positive charges, which means that we have to have 3 more protons than we do electrons. If we have 3 more protons than we do electrons, that means that we're going to have 23 electrons. And we can check. We need to have 26 protons because we're talking about iron, and 23 electrons because this iron is an ion and it has 3 extra protons. So do we have 3 extra protons than we do electrons? Yes. Then we know we did it correctly. Now I want you to do these check your understanding problems in your practice packet, and we are going to talk about them tomorrow. Remember, we have an atom of calcium, so this is neutral, an ion of calcium, and more specifically a cation because it's positively charged, an atom of fluorine, and an ion of fluorine. More importantly, a negative ion. So that is what you're going to work on, and we'll check your answer on Monday.